Good morning, everybody. It is June 2nd, 2020 at 10:41 in the morning here in Oshkosh, Wisconsin. We're going to be talking about the potential for severe weather in Wisconsin tonight across central and or southern Wisconsin. We'll dive right into it here. This is the infographic I created yesterday. It still applies, still showing a potential for some strong severe storms here, kind of emanating from the La Crosse, west central Wisconsin, heading east through this corridor, generally within that black encircled area. Let's go take a look at some of the outlooks today. This is the SPC convective outlook, showing an enhanced zone of potential for severe weather right across that zone, and then lighter amount. Northern Wisconsin, it's going to be probably not too much going on, maybe a thunderstorm or rain. North of a certain line, because south of that line, it's going to be severe weather. So kind of a cutoff there a little bit. And then southern Wisconsin, down towards the Wisconsin-Illinois border, you're going to be seeing activity probably later at night, overnight hours, and then it'll probably be in a state of weakening as it comes through those zones. That's the SPC outlook this morning. Here was my outlook for yesterday, and then I updated it just a few minutes ago. So it looks like this now, and it's very similar to that. So we're all on the same page with regards to where the severe weather is probably going to be. I only went up to a severe zone on this one. Now, if you're wondering, so going back to this again, wondering what this means, what does the red mean? That's a severe zone that I've added in. Here's what it generally means. Severe thunderstorms, large hail, damaging wind, tornado, potentially within that zone. I think this event's probably going to be more along the lines of a damaging wind threat with lesser risk for the large hail and tornadoes. However, you never know with severe storms, they're capable of everything. So we'll see. I'll explain why I think the way I do on that part. Now, if we look at the SPC, understanding their risk categories, the three that's here enhanced, it's not a high end amount. It's right there. It's above, it's about the average or a little bit above the average in terms of when we see severe weather. Numerous severe storms possible. Yes. So we're both on the same page there. So what's going to happen here? This is off of weather.cod.edu, the website. This is the high-resolution NAM model from 12Z, so this is really new information, and it's kind of showing the same thing. You're seeing storms breaking out here at 02Z, so that's pretty close to, let's see, so I have to go back to, because I have to do this. This is 7 p.m., 8 p.m., 9 p.m., so 02Z is about 9 p.m. So it's really late. It's not early afternoon, it's not mid-afternoon, it's more like late afternoon, evening, and into the overnight hours. You're seeing that taking shape out there, and you're seeing that probably you may have some cells that are more cellular there at the beginning when they first develop, but it's probably pretty quickly going to go over to a complex or a line of storms developing overnight. And then as we head towards 10 p.m. And then towards midnight here, you're seeing this complex move quickly across Wisconsin with a damaging wind threat potentially there, and it's a complex. I'm going to stress that much, and you know how that goes around here. You often get somewhat of it kind of looks. I'm not going to say bow echo. I don't think that this environment's really, super bad. I think it's more of a pretty typical classic Wisconsin wind event. All right, so that's that, and then as you go towards the morning hours, as I was mentioning, the Wisconsin-Illinois border by about 1 to 2 a.m. Timing is flexible, but generally speaking, like overnight into the very early morning hours, you're seeing that as that line moves through, it's probably going to weaken somewhat closer to the Wisconsin-Illinois border. This is, if you're not familiar with these, you don't have to understand, you don't need to be a meteorologist. I'll try to explain this to you in as much detail as I can and as quickly as possible. I'm just looking at the soundings here for basically, if you took a stab at this environment right about here at that time frame, if you look vertically through the atmosphere at all the layers, what does that look like? It's like a big, like a 40,000 foot flagpole, basically. So if you look at it here, you're seeing that like at the very base here, you have winds kind of coming out of the west. It's all unidirectional. So now I'm going to use meteorological terms. And if you are understanding how soundings work, then you'll know what I'm talking about. But you see, there's mainly a unidirectional signal here. The instability though is really good. Lapse rates are really good overnight. Basically, when I say unidirectional, it tends to be wind because supercells tend to form in more of a veered profile. This is not really that for that. Wind shear magnitudes are low, they're weak, so it's a weak wind shear situation. However, with the thermodynamics, you can kind of you can kind of I can't come up with the word right now, but basically I can't come up with the word, but maybe it'll come to me later. But basically, yeah, cover for. So with thermodynamics, you can cover for some of the deficiencies in terms of wind shear. But yeah, so that's what I'm looking at now. If I was really concerned, I would be looking at, we'd probably be seeing more wind shear in here, more veering, because then the bulwarkos and the bookend vortexes tend to favor and like higher shear environments. That's when they really get really bad. But this is sort of one step underneath that, in my opinion. This is really cool. I just want to show you the infrared simulation, or yeah, I think that's infrared. I call it infrared. Basically, IR is just showing you cloud tops at about overnight, because just to give you a feel for what a scale this could be on. It could be a widespread scale now. This is really just really cool to look at now. If you're looking from outer space there at midnight, you might see a bunch of clouds here over Wisconsin, a big surge of moisture into the upper atmosphere. Okay. Here's another thing I like to look at. This is from the same NAM model, just showing you these updraft helicity tracks. Now, where they end up precisely is obviously very much prone to change, but you're looking at a corridor, right? You're looking for corridors of severe weather, potentially, because those helicities are really going to be attached to the strongest updrafts and the most strongest storms. And the reds and the yellows you see are probably showing a corridor right through where we have that mapped out. So I've seen a lot worse from this, and I'm just saying it just seems to be supporting everything we've talked about so far. Now, we're going to take a look at the wind speed with height, and just to show you kind of a perspective on this event, at the 500 millibar level, 250, I want to start from 250, it's closer to a subtropical level, but you're seeing, there's nothing, I mean, it's strong, yes, as it should be, but you're not seeing any jets that are kind of feeding into the back. So this is at 03Z, so this is pretty close to 10 p.m. There's nothing really special about that. It's pretty typical for a severe weather event. 500 millibar, pretty typical for a severe weather event. I would like to see, for the worst of the worst, I would probably be looking for more of a jet, more organization behind that outbreak. But not seeing that there at the upper levels. So, but at the lower levels, you got your winds there. You're seeing from the top to the bottom mainly unidirectional wind flow. Okay, so that tends to lead to more line complex type situations, not as much supercells that way. But yeah, and then at the lowest level here, 925. I mean, when you look at the entire environment, you do see obviously the whole structure here. You see northerlies north of the warm front, and then you see southwesterly south of it. So on a regional scale, yes, there are colliding air masses there, but the layers are pretty much homogeneous, if that makes sense to you. Now, this is what caught my attention initially, was the instability reservoir that gets built here during the day, here today, Tuesday. So this afternoon, right now, it's building. The dew points are really cranking up, but here close to about 6 p.m. I got you show. This is NAM again, just showing you where this axis is going to be located. It's probably going to be pretty close to where the strongest storms go. So I know this shows it going right through Green Bay, and that may happen. I kind of tend to believe it might be a little bit further south, maybe into the valley or right across central Wisconsin potentially. I'm just to show you that there's definitely some energy there that could be tapped into. Those grays look like they're about, in the order of 4,000 to 5,000 cape. So that's 180 millibar mixed layer cape. That's really, really strong. That's strong instability for this time of year. Again, you have to balance it out with the wind shear to understand what kind of storm mode you're going to get. And then in this case, I'm saying it's probably going to be somewhat of a complex. But as you go through the overnight hours, even into even past midnight, you still have on the order of 3,000 to 4,000 cape there to work with. So instability is really strong. Again, with these type of events, you tend to see a lot of instability. With the MCS complexes, that's a pretty typical signature. I just wanted to show, this is the European, just wanted to show you this because I want to stress that the wind shear component, because for severe weather, you have several ingredients that you need, the wind shear being one of them, and it's on the weaker end, okay? So it's not the worst of the worst, but certainly potential for severe weather there. I mean, you'd want to see a lot more strength in that wind shear profile because it helps organize the storm a little bit. When a storm is disorganized, it tends to go sprawl, line out, go outflow, and sprawl out. It tends to lose its coherent. But in the right environments like tonight, you might have it where as that storm lines out, goes outflow, you have new updrafts forming along that outflow boundary as it goes through southern Wisconsin. So that's why there's a higher risk, spatially more of a widespread threat regarding this event. But here's the NAM high resolution again, dew point forecast for 7 p.m. tonight. So it thinks we're going to get into the lower 70s for dew point temperatures. And I know there's a lot of other models in here. They're kind of, NAM itself is pretty, the GFS, if I can find it. Yeah, they're all kind of saying, man, there's a lot of moisture, a lot of energy available with this storm. I know some models are not quite there. Looking at the current dew point temperatures, already at the 70s around La Crosse, and then in the upper 60s in eastern half of Wisconsin. So we're definitely on our way towards that lower 70 to 75 degree dew point not threshold, but reservoir kind of thing. So yeah, models seem to be on target with the instability. Just wanted to show you this. This is the 3-hour dew point change, just showing they're increasing. Looks like this black line here is about 2 degrees every 3 hours. In northern Wisconsin, 8 degrees every 3 hours. It's increasing, getting more and more moist there. So there's moisture is increasing across the state. This is just a convective model I wanted to show. This is the ARW. They're all generally now showing the same thing. I have to scroll this up just to show you. But if you look La Crosse area there, kind of coming through. Yeah, and that charges hard right across Wisconsin. So I don't expect it to really let up at all. Sometimes you see some weakening. I wouldn't expect that. I think it's going to charge right from west side to the east side. Yeah, potential damaging wind gusts. So there's that. I don't need that. But anyways, I got this all summed up. I'm going to do another update on this text version in a little bit. But basically, we've been covering this since Friday. Was the first post on it. Yeah, and then like I said, as this video ends, I'm going to go post this video there. So that's what I got for you. Stay tuned. Stay safe. I got a lot of content coming up with this event. I think I'll be chasing tonight. My plan right now is not to leave to go anywhere specific. I'm here in Oshkosh, right? I'm over in here, right in this zone. So my plan is sort of to stay here until about 6 or 7, and this will be an overnight chase for me. And that's dangerous, overnight chasing. But there's a different set of goals at nighttime for me. So we'll be probably somewhere in this zone, trying to figure out where the strongest portion of the storm is coming through. My mission is more in the terms of lightning, trying to get structure, photos with lightning illumination, and then covering the storm, live streaming it as it comes through so people can see that this is a legit thing. It's a real event. So that'll be what's going on tonight. Thank you for watching. Stay safe out there, and I will talk to you very soon.